Welcome back to this channel. So in this video we are going to be handling U.A.C.E pure mathematics. So this is a continuation of polynomials and we are going to be specifically covering quadratics. So this video is presented to you by U.A.C.E and you are advised to subscribe to the channel and share it to your friends so that you can benefit as a family. So with quadratics, we are going to start with maximum and minimum values of a quadratic equation. So with quadratics, we give you a quadratic equation, and that quadratic equation is going to be in this form: y being equal to ax squared plus bx plus c. And then, using the method of completing of squares, the above quadratic equation can be expressed in this form. So when you complete squares, our quadratic equation can be expressed in this form. It's either in this form or in this form. Now Roman number 1, we are saying that to get minimum or maximum values, you let the squared component after completing square to be equal to 0. So that's the reason for this statement, and we are saying that since the squared component, which is our squared bracket, is never negative, always the least value of y occurs when the squared component, and in this case is always the bracket, is equal to 0. So that's when you get the minimum value or maximum value of y. And we are saying that the same applies to Roman number 2. So in Roman number 2, we are telling you that y is being equal to 2 minus a square bracket of x minus p. Now you're saying that since x minus p is never negative, still the maximum value of y is going to be given by 2, because we say that whenever you're getting maximum or minimum, always the bracket is equal to, the squared bracket is equal to 0. So we are going to be looking at my example so that we can further understand the concept. So these are the examples given, and they are telling you to find the greatest or least values. Now remember that the greatest or least values of any function are the same as, greatest is the same as maximum and least is the same as minimum. So part A, we are going to be solving. The first thing is to first complete squares, and we are going to be looking at how squares are completed. So let's take a look at the next slide so that we can further look into this. If you are to start with Roman number 1 or part A, we are saying that by completing, for us to get minimum or maximum values, the first thing is to first complete squares. So completing squares for this. Now whenever you are completing squares, the first thing you should ensure is that the coefficient of x squared must be positive 1, and if it's not positive 1, you should do prime factorization so that you can make it positive 1. The other thing is, to complete squares, we get the coefficient on x, I mean this one. So if you look at x, the coefficient is negative 2, and then you have the coefficient. After having the coefficient, you square it and you add it and you subtract it to that very equation. And this is what we did in this step. So the coefficient of x, we saw that is negative 2. So we get negative 2 and we have it. After having it, we square it and we add it and we subtract it on that very equation. So when you're completing squares here, we saw that x squared minus 2x, now we do what I told you. So this is a step. You have the coefficient of x, which is negative 2. So it's halved, and then after you square it, you add it and then you subtract it, so that there's no meaning, or the question is not changed. And then plus 5, which was already present in the question. So proceeding, if you have negative 2, you get negative 1. So this will be like negative 1 squared, and you get 1. And this will be negative 1 squared, you get minus 1. So summing up this, you realize that this is a perfect square. You are always going to get a perfect square. So if this is the perfect square of x minus 1, this is a perfect square of x minus 1. So implying that always you are going to get a perfect square after expanding, and that's the aim of completing squares. So you get -1 plus 5, you are going to get +4. And then always the first three components are going to give you a perfect square. So you realize that this one is the expansion for this bracket. So we condense it back. But if you open this bracket back, you must get the above value. So you should always be able to say perfect squares. And then you're saying that y, but our y was equal to this. And again, but you have already computed square for this. So therefore, you can express that in this form. And we have said to get minimum or least value, you always equate the bracket to 0. So if this bracket is equal to 0, that means that the minimum or least value of y will be equal to y is equal to 4 plus 0. That's why we are saying that the least value of y is therefore 4, and it occurs when the squared component of our completed square equation is equal to 0. So going on to part B. Part B, like I said, always you should ensure that the coefficient of x squared is +1. So in part B, we prime factorize out negative to make the coefficient of x squared +1. And also you make sure that everything containing x we entangled it, because that's all we need for us to complete squares. However, another person can prime factorize out the negative generally. Answers are going to remain the same. So we follow the steps. To complete squares, we only need two values containing coefficients of x. But starting, you first make sure that the coefficient of x squared is +1. And then the other value of x power 1, we get its coefficient. The coefficient here is now 2. We square it and we half it, first of all, like we did in the first equation. And then we square it, we add it, and we subtract it on either sides. So if you do that, you are going to remain with, now if you look at 4, if you have 4, you are going to remain with 2. And then if you square 2, you add it. Like here, I squared 2, that's why I got here 4. You add it here, and then you subtract it. If you subtract 2 squared, you're going to get 4. And if you open up bracket, you're going to get the negative is going to turn to a positive. So this one was a bit unclear. It may confuse you, but you should follow up what I did. Or I'm going to make it very clear in the other steps. So you are going to get +4, and then you rearrange 4 plus 5, you are going to get 9, and then minus your perfect square bracket, which is of x plus 2. So the minimum or the greatest values occur always when the squared bracket is equal to 0. So therefore, it will be y greatest will be equal to 9 minus 0, which will remain y is equal to 9. So let's look at further details. Let's look at that explanation from part C and let's see what you missed out. So the first thing is to rewrite your equation. And after writing your equation, you notify the coefficient of x. First of all, the coefficient of x squared is +1, so that's okay. So we start completing squares. To complete squares, we look for the coefficient of x, which is -3. Now you have -3, that means that it will be -3 out of 2, and then you square it. When you square it, you are going to get 9/4. After squaring, you add it and you subtract it, so that you leave the equation without changing it. When you have added and you have subtracted the same thing, we have done nothing to the equation. And then +5, which was already present in the equation. So always the first three components are going to give us a perfect square. And always that square the sign that is present on the coefficient of x is always the sign that you go with. So this is a perfect square, and you find that it's a perfect square of x minus 3 over 2. And then if you add negative 9 over 4 plus 5, you're going to get positive 11 over 4. Rearranging will give you this. And then to get the least value, always you get the bracket that is squared and you equate it to 0. So doing that, we shall have y, the least value of y being equal to 11, because if we make the squared bracket 0, well, the least value of y will be equal to 0 plus 11 over 4, which will give you 11 over 4. And we are saying that it occurs when the square bracket is equal to 0. So going to part D. Part D was like this. Now part D, the coefficient of x squared was not positive 1. So what do? We prime factorize. Now in prime factorizing, you prime factorize out 2, and I told you only need 2 values. That one for the first beginning values, that one containing x. So we have, after ensuring that the coefficient of x squared is positive 1, then we go to completing squares. When you're completing squares, you only need the coefficient of x. Now in this case it's negative 2. You half it. Halving it is the first thing. So it will give you negative 1. And then you square it, you add it, and you subtract it from the equation. So when you get that, now I skipped a lot of steps here, but there are not many. First of all, you can include them in your notes. When you have the coefficient of x here, it's going to be negative 1, and when you square it, you're going to get positive 1. When you also that means that we're going to add the squared component and we subtract it. So we shall have plus 1 minus 1. But remember, we shall be doing that in the bracket. So after opening up the bracket, the 2 multiplies the negative 1, and we get negative 2. And then negative 2, we add it to the 5, which was already present. So this one remains 1 because we didn't open up bracket for it. But the other component of it that we subtracted, we opened up bracket for it, that's why it turns to negative 4. And like I said, always the first components are going to give you a perfect square. So you condense it back. So you find that the perfect square of x squared minus 2x plus 1 is going to be x minus 1. So rearranging, we shall have negative 2 plus 5 to give us 3. And then plus 2 into the bracket of the perfect square of this is x minus 1, which is squared. So the greatest or least values are going to occur when the squared bracket is equal to 0. That means that the least value of y is going to be equal to y equals to 3 plus 0. And the least value of y is going to be 3, which occurs when the squared bracket or squared component in our equation is equal to 0. Now looking at part E, first of all, we have to first make the coefficient of x squared positive 1. So that's why you prime factorize the negative. You're going to remain inside the bracket with x squared minus x. Now after doing that, we complete squares. The coefficient of x is negative 1. So we halve the coefficient of x. We are going to get negative a half. Now after halving it, you square it. On squaring it, you are going to get 1 out of 4. Now you add this 1 out of 4 and you also subtract it. That's what we did. So when you add it and you subtract it, you add it within that bracket. Now here, for me I skip that step, but you do everything within the bracket. Then after, you open the brackets later. So for me, after adding negative 4, so you find that the negative, when you're opening brackets, this negative will affect this one. So the negative 1 over 4 will be multiplied by this negative, and you end up with a positive value. And I've told you that always the first 3 are going to give us a perfect square. To take the sign that will be in the perfect square, you always consider the sign on the coefficient of x. That's why you're having x minus a half. So that's the perfect square for this, and you ensure that when you expand this bracket of yours, you can go back here. That's how you can prove your answer. So proceeding, you rearranging, we shall have x7 minus this perfect square, then plus a quarter. Then 7 plus a quarter, you're going to get 29 out of 4. Then minus your square bracket of x minus a half. So the list of greatest value occur when the square bracket is equal to 0. So that means that the greatest value of y is going to be equal to 29 over 4. And it occurs when our squared bracket is equal to 0. Now we do the same for part G. For part G, the coefficient of x squared was negative. That's why we started by prime factorizing. After doing that, you get the coefficient of x. It's negative 2. You half it, you are going to get negative 1. Then you square it after halving. You are going to get 1. Then you add 1 and you subtract it. You do that within the bracket. And then you only let the one you are subtracting out of the bracket. So you find that this negative which was here will affect it here. So instead of minus 1, it will be multiplied by the negative that was outside the bracket and return to positive 1. Then inside, the first three components are always going to give you a perfect square. So that perfect square is always for x minus 1. And rearranging, we shall have y is equal to 1 minus the perfect square of x minus 1. So your greatest value of y is going to be 1, and it occurs when the bracket square is equal to 0. So if they ask you the point at which the x value is, for the greatest value, we have said that the square bracket is always equal to 0. So you make x the subject. Making x the subject, you always find that x will be equal to 1 for this case. The value of x will always vary. So going to the sum, proceeding, we are going to go to the sum and product of the roots of the quadratic equations. So you're saying that to before, now this is very important. This is very important. Before handling questions for sum and product, this should be your first step. As number 1, the coefficient of x squared must always be positive 1. So whenever you're given a quadratic in this form, the first step is to divide and to make the coefficient of x squared to be positive 1. That means that you're going to divide through by its coefficient. So doing that, you're going to remain with x squared plus b over a x plus c over a being equal to 0. Now continuing, you're saying that suppose alpha and beta are the roots of the above equation. So we write our equation like this. So you're saying that suppose alpha and beta are the roots of the above equation. How are we going to get the sum and how are we going to get the product? So you're saying that the sum, alpha plus beta, remember that these roots are for the above equation. That's why we are writing them in this way. So alpha plus beta is always going to be equal to the negative. Now this is very important. The negative is there by default. Negative coefficient of x. So if you look in our equation, the coefficient of x is b over a. So sum of roots, alpha plus beta is always the negative. The negative is by default negative coefficient of x. You go to your equation and you pick your coefficient of x. So you find that it's going to be negative b over a. Whereas the product is always the last value without any coefficient of x. So we're saying that the product alpha beta is going to be equal to c over a. So proceeding, we are saying that for quadratic function with roots of alpha and beta, that means that our sum of roots alpha plus beta is always going to be negative b over a, and our product of roots is always going to be c over a. Now these are some of the important expansions in mathematics, and you need to pay attention to them because these are the things that we keep examining in your papers. So you're saying that if you're given roots of alpha squared and beta squared, how are you going to get their sum? So alpha squared plus beta squared, if you remember this expression, if you remember this expansion, we make this will be equal to this. you expand alpha plus beta, alpha plus beta squared, you'll find that it will be equal to alpha squared plus beta squared and then plus 2 alpha beta. So how can you make alpha squared plus beta squared the subject? You'll find that we shall take 2 alpha beta this side, and that gives us the origin of expression 1. And we do the same thing with the others. So if you look at alpha cubed plus beta cubed, its expansion is always going to be this. Now these formulas are available in your logbooks. Whenever you always get confused, you always refer to your logbooks and you take these expansions because we provide them so that you can avoid making mistakes in your papers. So alpha cubed plus beta cubed will be equal to alpha cube bracket of alpha plus beta minus the product of alpha beta into alpha plus beta. Now the other expression that will disturb many is alpha minus beta. Now you realize that alpha minus beta we don't have it, and we say alpha minus beta can be got by squaring, having the square root of alpha minus beta squared. Now the reason why we do this is because we can't get the subtraction of alpha minus beta. So we have to put them in a way where we can get addition signs. And the only thing to do that is by squaring and getting a root. So when you square that bracket, you are going to get alpha squared minus 2 alpha beta plus beta squared. Now you merge up the two. So alpha squared plus beta squared, you bring them together, and the product of the roots, you also bring them together. But remember, we have already given an expression for alpha squared plus beta squared. So you bring it up. So bringing it up is going to give us the square bracket of alpha plus beta, then minus 2 alpha beta, and then minus the 2 alpha beta which was already present. Then if you subtract, you are going to remain with the square bracket of alpha plus beta less 4 multiplied by product of alpha beta. So this is another expression that you need to pay attention to. So in your revision book, you should always know how to derive the 3 expansions. So first of all is this one, second of all is this one, and the first of all is this one. Now provided you are given roots of fractions or reciprocal roots of 1 and alpha, 1 over alpha plus 1 out of beta. Now this is always the sum of roots. How are you going to deal with such roots? You are going to find the LCM first. So when you find the LCM, you always find that you're having the product of roots and you're having the sum of roots. So product of roots is always going to be equal to 1 out of alpha beta. And thus we are saying that the following expansions are therefore important in math. The alpha squared plus beta squared are always going to be alpha plus beta squared less negative 2 alpha beta. And alpha cubed plus beta cubed is always going to be equal to cube bracket of alpha plus beta minus 3 alpha beta into alpha plus beta. And alpha minus beta always is going to be equal to alpha plus beta squared less 4 alpha beta. Now you have to do numerous questions about this topic so that you can keep in use of these formulas, otherwise you're going to forget everything. Look at this example. In this example, they are telling you that provided alpha and beta are the roots of this equation, state the values of alpha plus beta, the sum of roots and product of roots. So let's start with that. First of all, you have to first make sure that the coefficient of x squared is positive 1, and they gave us positive 1 as the coefficient. So what we need to do is to identify the sum of roots and product of roots. And we already say that the sum of roots is always equal to negative coefficient of x. So in this equation, our coefficient of x is negative 1. So that means the sum of roots is going to be equal to negative coefficient of x, which is negative 1. So negative and negative multiply each other and remain with 1. And the product of roots is always being the value that is not attached to any variable of x. So alpha plus beta is going to be equal to -3. This is the only value that is not attached to any x variable. So let's start answering the questions. If you look at part A, they have told you to find an equation or to state or to express in terms of sum and product the values of part A, alpha squared plus beta squared. Now we give that expansion. Always what you should aim at when you are solving these equations is to make sure that your work is in terms of alpha plus beta and alpha beta. Once you get that, don't proceed. And you have already given expansions for alpha squared plus beta squared, which is the same as square bracket of alpha plus beta less 2 alpha beta. So you just substitute since you have already got the values. So sum of roots, you saw it's +1. So you substitute it, and you should indicate brackets to show that you're substituting. You'll get a bonus mark for that. And product of roots is -3. You also substitute for it. Then you open up brackets, you remain with 1 less -6, and then you remain with +7 as your final answer. Now when you look at part B was given in a form that you first expand, because all we want to do, we want to get an expression having only alpha plus beta or alpha beta in form of either sum of roots or product of roots. So expanding the bracket of alpha minus beta squared, you are going to get alpha squared plus beta squared less 2 alpha beta. Then you collect the terms according to powers. So alpha squared plus beta squared less 2 alpha beta. Then this expansion is already given in your logbook, and it was also given in these notes. So you substitute for it. You say, but that expansion is equal to bracket of alpha plus beta squared minus 2 alpha beta. So in substituting for it, you're going to get this. You're going to get a square bracket of alpha plus beta less 4 alpha beta. Now once you get your expressions in terms of alpha plus beta and alpha beta, the only thing you have to do is to substitute. So that's why for alpha plus beta, we already have that mark. For alpha plus beta, we got 1. So you substitute for 1. And for alpha beta, which is product of roots, we got -3. You substitute for it. So you remain with 1 squared. You remain with 1 squared plus 12. Because -4 times -3, you get +12. So you remain with 1 plus 12 to get 13. Now you go to part C. Part C, they gave you an original or standard formula, which is already available in your logbooks. So alpha plus beta cubed is equal to cube root of alpha plus beta minus 3 alpha beta into alpha plus beta. Now since this one is in terms of either alpha plus beta or alpha beta, what you do is we just substitute. So where there is alpha plus beta, you put the sum of roots, which is 1, and where there is alpha beta, you put product of roots, which is -3. And then you open up brackets, you remain with 1 plus 9. Then you add to get 10. Example 3, you are told that alpha and beta are the roots of this equation. Find the values of alpha plus beta. This is the sum of roots. Part B is requiring product of roots, and part C wants you to further simplify this statement or that question in terms of either alpha plus beta or alpha beta. And the same applies to part D, the same applies to other parts. So starting with part A, the first thing to do, I told you, you always make sure that the coefficient of x squared is +1, and the way we are going to do that here is dividing both sides by 2, or each and every element by 2. And once you do that, you remain with x squared. You're going to remain with x squared minus 5 over 2x plus a half being equal to 0. So if you start answering questions, alpha plus beta refers to the sum of roots, and sum of roots is equal to the negative coefficient of x. So the negative comes by default. So alpha plus beta is going to be equal to the negative coefficient of x. and the coefficient of x here is negative 5 over 2. So when the negatives multiply, you're going to get with the positive value of the coefficient of x, which is 5 over 2. And then the product is always that value without any attachment to x, which in this case, after dividing, making the coefficient of x squared positive 1, you're going to remain with a half. So our product of roots is equal to a half. So that was part A and part B. So let's go to part C. Now part C, always such equations require you to put terms in either alpha plus beta or alpha beta. Now once we do that, we are going to group terms according to their powers. So you group alpha squared and beta squared together, and then you also group the others together. Now remember that this is already in alpha beta form. You don't need to expand for it. But otherwise, you need to substitute for it because you have already got it in part B. What you want is substitutions. And what you want is this expression to be in terms of alpha plus beta or alpha beta. And in simple terms, to be in terms of sum of roots or product of roots. So this expression was already given at the start of the notes. And you say that it's also available in the logbooks. So if you substitute for it, it's the same as the square bracket of alpha plus beta raised to alpha beta. And then you add on these 3 alpha beta. So negative 2 alpha beta plus 3 alpha beta, you're going to remain with alpha beta and the square bracket of alpha plus beta. Now your expression is already in the form of alpha plus beta or alpha beta. What you need to do is substitution only. You don't need to further expand. So substituting for alpha plus beta, which is the sum of roots of the equation, we got it as 5 over 2 in part A. And substituting for the product of roots is a half, which we got in part B. Squaring the bracket, you are going to remain with 25 over 4, then plus a half. And adding the 2, you are going to get 27 over 4. Now the same thing we do to part D. First of all, we group terms according to powers, and we leave out the others with single powers. This one has already known substitution. We substitute for it. So negative 2 alpha beta minus 3 alpha beta, you're going to get negative 5 alpha beta. Then you substitute, since you are having alpha plus beta or alpha beta, which is the main aim of quadratics, you substitute for it. Sum of roots is 5 over 2 squared minus 5 into product of roots, which is a half. So you remain with 25 over 4 less 5 over 2. And then finally, you'll get 15 over 4. So part D, we are given this expression. Now whenever you are given such things, always in polynomials you aim at prime factorization. So you prime factorize out the common thing. You find that alpha and beta were common. Now in prime factorizing them out, we remain with alpha squared plus beta squared. Now we further expand our bracket because this one has a standard expansion according to the notes we began with, and also it's present in the logbook. So if you don't have a logbook, you are advised to purchase one. So alpha beta, the expansion of this is the same as square bracket of alpha plus beta minus 2 alpha beta. Now this is the sum of roots and this is the product of roots. You substitute for them because you got them in part A and part B. So sum of roots is 5 over 2, which is going to be squared, minus 2 multiplied by the product of roots, which is a half. Expanding the bracket and multiplying a half, negative times half, you get negative 1. And 5 squared, you're going to get 25 over 4. Now I didn't make that here, and that was a mistake. So when you're doing it, you make sure that you rectify that. And I think the answer will also change. So take note of that. So going to part F. Part F, we are adding reciprocals over roots. And we say that when you're adding reciprocals over roots, the first thing to do is finding LCM. So the LCM is going to be alpha beta. Once you divide LCM by beta, you're going to get alpha. Alpha times 1, you're going to get alpha. When you divide LCM by alpha, you're going to get beta. Beta times 1, you're going to get beta. So since our expressions are in terms of alpha plus beta and alpha beta, then we substitute. So you find that sum of roots is upwards, which is the same as alpha plus beta. So you substitute for it as 5 over 12. Then divided by our product of roots, which in this case is a half. So simplifying, you get 5 as your final answer. Now proceeding to example 4. You are being given the following roots and the given equation. Now for this equation, I told you the first thing is to make the coefficient of x squared to be positive 1. So that means that your equation is going to be, you divide through by 6. So your equation is going to be in this form. That's the first thing to do. It's going to be, now if you divide by 6, you're going to remain with a third. 1 over 3 as the coefficient of x. Now once you divide negative 3 by 6, you're going to remain with negative half. And once you divide 0 by 6, you're going to remain with 0. So that means that your sum of roots, since the roots we are having are alpha plus beta, alpha and beta, sum of roots alpha plus beta is always equal to the negative component. Is always equal to the negative. Now realize that this one was positive, as indicated here in the question. So alpha plus beta is always equal to the negative coefficient of x. So you first read the negative and you go and you look for the coefficient of x, which in this case is a third, which is positive. So negative times a third, you're going to end up with negative a third. So pay attention to that. Then what about product of roots? Product of roots is the other value without any variable of x attached to it. So in this case, our product of roots alpha beta is going to be equal to negative a half. So we start with part A. Now if you look at part A, whenever you're given such fractions, the first thing to do is to find LCM. And LCM is, in this case, is going to be alpha beta. Once you divide the LCM by beta, you're going to get alpha. Once you multiply alpha by the alpha in the numerator, you're going to get alpha squared. And then once you divide the LCM by alpha, you're going to get beta. And then once you multiply beta with the numerator, you're going to get beta squared. Now the component in the numerator has a standard expression, and you're going to find this one repeating also in your revision, which is present in the logbook. So the standard expression for this is alpha plus beta squared raised to alpha beta divided by alpha beta. Now our sum of roots, I've already shown you how we get them. So our sum of roots is negative a third and product of roots is negative a half. So as indicated here, this is our product of roots. So once we substitute alpha plus beta, this is sum of roots, so it will be negative a third squared, and our product of roots is a half, so it will be negative 2 into a half divided by a half. Now many students make mistakes here with their calculators. Your advice is to do 1 by 1 like I did here. Use first simplify 1 by 1 and then substitute everything in the calculator later, but you must make sure that you use brackets because you lose a lot of marks on this step. So remain with, in the numerator, you're going to have a 9th plus 1 divided by negative half. Now in simplification, you're going to get negative 20 over 9. Therefore, alpha divided by beta plus beta divided by alpha is going to give you this answer. So proceed to part B. Part B, do the same thing. If fractions are given, whenever fractions are given, you make sure that you find LCM. So the LCM is going to be alpha squared and beta squared. So once you divide alpha squared and beta squared by beta, you're going to get alpha squared, and alpha squared times 1, you're going to get alpha squared. That's why alpha squared is here. And once you divide alpha squared beta squared by alpha squared, you're going to get beta squared. And once you multiply beta squared by 1, you're going to get beta squared. Now this one, the numerator already has an expression or substitution for it, which we have been covering all along. So the expression for that is the same as square bracket of alpha plus beta raised to alpha beta. Then this one in indices, you prime factorize out the square and you remain with the bracket of alpha beta squared. Now you substitute for the values of alpha plus beta or alpha beta. Like I told you, in quadratics, our main aim is to express everything in terms of either alpha plus beta or alpha beta. So substituting for alpha plus beta, you have negative a third squared, and substituting for alpha beta, you have negative a half, which is presented in the equation. In substitutions, you always use brackets to get most of the marks and to avoid unnecessary mistakes. So computing, you remain with a ninth plus 1 divided by a quarter. Dealing with the numerator alone, you're going to get 10 over 9 divided by a quarter. And simplifying using a calculator, you're going to get 40 over 9. Therefore, you come and conclude, implying that the expression that has been given in the question will be equal to 40 over 9. Now in polynomials or quadratics, it's advisable to give your answers in fraction format because it's more accurate. Now if you go to the part C still you're having somewhere where LCM is required to get. Once you're having anything where LCM is required to get, you always start with that one. So if found LCM, now this is like 2b divided by this fraction. So we shall get reciprocal and we end up with 2 alpha beta divided by alpha plus beta. Now you substitute for the product, you also substitute for the sum, and remain with negative 1 divided by negative a third. And lastly you get 3 as your final answer. So you see that implying that the expression which was given will be equal to 3. Now part C, you are given a standard expression. Alpha cubed plus beta cubed according to the logbook is equal to cube bracket, the cube bracket of alpha plus beta minus 3 alpha beta into alpha plus beta. Then you substitute for each. So substituting for alpha plus beta, you have cube bracket of negative a third minus 3 product of negative a half and negative a third. Expanding the brackets, you are going to get negative 1 over 27 minus a half. This is after simplification. And getting the final answer, you are going to remain with negative 29 out of 54. And looking at the final part, it was also given in terms of fractions. For fractions, start by finding LCM. Let me hope you have been following up or been handling LCM explanations. So you remain with that in the after simplifying. But the component in the numerator has a standard equation in the logbook, which you're allowed to go with in the exam hall. So you substitute for it. Say that your expressions, you also use indices to prime factorize out 3 as a power. So that you remain with alpha beta into cubed. Now since your expression is read in terms of alpha plus beta and also alpha beta, the only thing you need to do is substitutions. So alpha plus beta is the same as negative a third. That's why you put it there. Cubed always substitutions are indicated by brackets and they carry a mark. So the more you use brackets, the more you avoid unnecessary mistakes. And the more you avoid brackets, the more you make unnecessary mistakes. So in the numerator, we shall remain with negative 1 out of 27 less a half divided by negative 1 over 8. So solving the numerator alone, you're going to remain with negative 29 divided by 54. And everything is going to be divided by negative 1 over 8. Now simplifying, you're going to remain with 116 divided by 27 as your final answer. Now going on to the essay questions as presented by UNEB. You are being told that given alpha squared and beta squared are roots of this equation, and alpha and beta are both positive, find alpha beta and alpha plus beta. In other words, they're telling us to find the sum of roots and product of roots. So we're going to start where we're going to start from. Now let's start. The coefficient of x squared in this equation is already 1, so there's no need for division. So since alpha squared and beta squared are the roots of the equation, that means sum of roots, which is going to be alpha squared plus beta squared, is going to be equal to negative value, the negative of coefficient of x. So in this term, the negative I told you is by default. So in this time, the coefficient of x is negative 21. So opening up the brackets, you're going to remain with 21 as your sum of roots. Then your product of roots is always the other value without any coefficient attached to it. So alpha squared beta squared is equal to 4. Now trying to simplify, if you are to look at what was given, alpha squared plus beta squared has a standard substitution, and that is always equal to square bracket of alpha plus beta less negative 2 less 2 alpha beta. And then if you make alpha plus beta the subject, remember that if you square out here, alpha beta is going to be equal to 2. So that's why we substituted for this. If you look at this equation, the first expression, you square both sides, you are going to remain with alpha beta being equal to 2. So if you make alpha plus beta the subject, you're going to get 5. However, this was a question which was not properly set. It's very hard to set such twisted questions. So let's take a look at one of the good examples involving quadratics. So you are given this equation. Now this should be your assignment. You should try it out and you see whether you're going to get the same values as mine, because you have talked about each and everything here. So you pause the video and you take the notes. These are some of the solutions. For those of you who have tried it out, these are some of the solutions of the different parts. Like as I've told you, everything remains the same. So if you look at your equation, your sum of roots is going to be negative coefficient of x. So negative by default, and coefficient of x was negative 2. So if both of the two multiply, you get 2. And product is the other value without any value of x attached to it, which was 3. So finding sum of roots for part B, these are fractions, so you have to start by finding your LCM. And the numerator is always sum of roots, which is 2, and the denominator is always product of roots, which is 3. So that means that your sum of roots which are given was 2 over 3. So what about product of roots? Product of roots, you multiply the 2. So multiplying the 2, you are going to end up with 1 divided by alpha beta. And alpha beta is the product of roots, so we substitute for it and it's 3. So forming an equation, we always form quadratic equations in this form. They are always in the form of x squared minus the bracket of sum of the roots, x, plus product of roots. And substituting for them in this equation, so your x squared is here, your sum of roots is going to be here. All you need to do is substitution. Now here, it's preferable, you can either leave it in this way, or you make it linear by multiplying it out by the LCM, and in this case the LCM is going to be 3. Now going to part C, you are given the roots of alpha squared and beta squared. So if you sum up these roots, what are you going to get? I told you this is a standard expression. You're going to get square bracket of alpha plus beta minus 2 alpha beta. Then you substitute for them. Since your expression is now in terms of alpha plus beta or alpha beta. So substituting, you're going to get 2 squared minus 2 into 3. You remain with 4 minus 6, and your answer will be negative 2. And this is our sum of roots. If you go to our product of roots, you have alpha squared multiplied by beta squared, and then using indices, you prime factorize out the power outside the bracket. You remain with the square bracket of alpha beta, and alpha beta is the same as 3. So 3 squared is equal to 9. So the equation is given by x squared minus bracket of sum of roots of x plus product of roots being equal to 0. So don't forget the 0. So what you do is to just substitute x squared minus your sum of roots, you got it as -4, -2. Then your product of roots was +9. So you simplify and you get x squared plus 2x plus 9 is equal to 0 as your final answer. So in part D, you are given fractions, whereas when you are given fractions, especially sum of roots, you start by finding LCM. The numerator we have a standard quadratic equation, and this expansion is given the logbook. So whereas when you are going for paper 1, you take your logbook and you see such expressions if you feel like you forget them. So since the expression is in terms of alpha plus beta or alpha beta, what you need to do next is to substitute, and substituting is going to give you 2 squared minus 2 multiplied by 3 divided by 3. So you remain with 4 minus 6 divided by 3, and then you remain with -2 over 3. So continuing, you are going to have your new product of roots. Alpha divided by beta multiplied by beta divided by alpha. So if you see properly, all these ones are going to cross out, and you remain with 1 as your product of roots. So proceeding, an equation is given by x squared minus sum of roots of x plus product of roots being equal to 0. So what you have to do after getting sum of roots and product of roots is substitution. So you substitute for them, and then you make your equation linear by multiplying through by the LCM, and in this case it's going to be 3. This negative multiplies this negative and you get positive. So multiplying through by 3 is going to give you this. Then you proceed to part E. Part E, you are given these roots, and then you are going to follow the same procedure. You find the sum of roots, you end up with 0. Product of roots, you end up with this. Now usually you are going to end up with these expressions. What you have to do is to prime factorize. Once you prime factorize, you are going to end up with positive expressions, and this is a standard expression. You get your logbook and you find the substitution for it. After getting the substitution, so this negative multiplies this negative and you get positive 2 alpha beta, and then you add it to this one to get 4 alpha beta, then minus the square bracket of alpha plus beta. Now since our expression is in terms of alpha beta or alpha plus beta, we substitute. Product of roots was 3 and sum of roots was 2. So you remain with 12 minus 4, which is going to give you 8. So giving an equation is always given in the form of x squared less sum of roots of x plus product of roots being equal to 0. So you remain with x squared minus our sum of roots has been 0. You put it there, plus 8 is equal to 0. Simplifying will give you x squared plus 8 is equal to 0 as your final answer. Proceeding to question 8, example 8. Now you are being subjected to a lot of examples because students have excuses for this topic. I'm giving examples to see how you can better be good at this topic. Everything has been touched. The continuation, which is for polynomials and remainder theorem, has also been uploaded on this channel. So make sure that you watch the video immediately after this one. So given this equation, what I told you that if the coefficient of x squared is not positive 1, you start by dividing. So your new equation is going to be what? You find that your new equation, we make sure that our coefficient of x squared is positive 1. So that means that your new equation is going to be 7 divided by 2x less negative 3 over 2 being equal to 0. So you find sum of roots. Sum of roots alpha plus beta, because alpha and beta, they are the variables that were given, is always equal to negative coefficient of x. So negative coefficient of x, negative is by default, and then you find the coefficient of x. So in this case it was positive 7 over 2. That's why you ended up with negative 7 over 2 being your sum of roots. Let's try to eliminate this. So product of roots is always that value without any coefficient variable of x, which in this case was negative 3 over 2. Then you refer to the question. The question is telling you to find the equation whose roots are these. You always start with the sum or product, depending on what you want. So finding sum, obviously you correct the fractions together and you also correct non-fractions together. So non-fractions are alpha plus beta, and the fractions together were 5 over 5. The fractions had 5 in common. That's why I prime factorize it out, and then remain with alpha divided by beta plus 1 out of alpha. So adding the two, you are going to remain with the numerator. You are going to have alpha plus beta divided by alpha beta. Now, since our expression entirely is in terms of alpha plus beta and also alpha beta, then there you are allowed to substitute. So alpha plus beta is our sum of roots. We bring it as negative 7 over 2. And then in the numerator, we put it here, it's sum of roots. In the denominator, it was product of roots, which is negative 3 over 2. Using a calculator to simplify this, you're going to end up with negative 35 over 3, then plus negative 7 over 2. Using a calculator to simplify, you're going to end up with negative 91 divided by 6. And then this is your sum of roots. So you go and find your new product of roots. So to find new product of roots, you multiply the two brackets, and then you open them simultaneously and carefully. Now opening that bracket, you're going to have alpha beta plus 5 plus 5 plus 25 over alpha beta. But alpha beta is the same as our product of roots, so we substitute for it as negative 3 over 2. Then 25 divided by alpha beta. Our alpha beta is the same as product of roots, so we substitute for it as negative 3 over 2, then plus 10. Using a calculator to simplify all this, you are going to end up with negative 49 over 10. And then this is your formula for finding an equation of a quadratic roots, which is always given by x squared minus sum of roots of x plus product of roots being equal to 0. So what you have to do is to substitute. Your x squared is here. Your sum of roots, you got it as negative 91 over 6. And then your product has been negative 49 divided by 6. Everything being equal to 0. Making everything linear, you're going to get this as your final answer, or as the equation that was required. Now, since example 9 is having the same idea, I'm just going to peruse through very fast. So first of all, you are given a quadratic equation, but the coefficient of x squared is not positive 1. So what you have to do is to first divide through so that you can get positive 1 as the coefficient of x. So what do we do? We divide through by 4. So any equation will be x squared plus 7 over 4x minus 5 over 4 is equal to 0. That means that your sum of products alpha plus beta is going to be the negative coefficient of x, and the coefficient of x in your equation will be 7 over 4. So negative coefficient of x is going to be your sum of roots. Now in this case it's going to be negative 7 over 4. And your product of roots is the other value without any variable of x attached to it, which is going to be negative 5 over 4. So you get the roots that you are given and you find sum of roots. You prime factorize all the common things, you remain with alpha plus beta minus 2. Then you substitute for the sum of roots, which is alpha plus beta, which is negative 7 over 4. Opening the bracket, you're going to end up with negative 14 divided by 4, less 2. And solving, you're going to end up with negative 20 divided by 4. Final answer, you end up with negative 11 divided by 2. To proceed with the product of roots, you multiply the two brackets and opening them simultaneously one by one, you end up with 4 alpha beta less 2 alpha less 2 beta plus 1. So what we do here, we prime factorize out negative 2 and remain with negative 2 outside alpha plus beta. So since our expression is in terms of alpha beta and alpha plus beta, you're allowed to substitute. So alpha beta is the same as product of roots, which is negative 4 over 4. And alpha plus beta is the same as sum of roots, which is negative 7 over 4. So you substitute and you use a calculator to simplify. So you end up with negative 5 plus 14 over 4 plus 1. Finding LCM, you can skip this step and you just put everything in the calculator. So you end up with negative a half as your final, not as your final answer, but as your product of roots. So you use the formula for finding an equation of any quadratic, and you just substitute, and the formula is always the same: x squared less sum of roots of x plus product of roots being equal to 0. Always don't forget the 0 and the equal sign. So what you have to do is to just substitute. And then to make your equation linear, just multiply through by the LCM. So you remain with, now there must be 2 here. You remain with 2x squared plus 11x minus plus 1 being equal to 0. So edit this. So that was it for this statement. That was it for this question. Here we are going to be going through UNEB questions one by one, but since I've already introduced the concept, I'm just going to be very quick and we just barrel through just as a revision. So in UNEB this year, you are given that if the roots of the equation x squared plus 2x plus 3 is equal to 0 are going to be alpha and beta, form an equation whose roots are the following: alpha squared minus beta and also beta squared minus alpha. So we're going to approach that. Always first ensure whether the coefficient of x squared is 1. So in that case it was 1. So you have no need to worry. Sum of roots is always going to be negative. Negative is by default coefficient of x. So the coefficient of x here was 2. So to get sum of roots is going to be negative 2 as indicated here. Product of roots is a component, the positive component of the other variable without any coefficient of x in our equation. Therefore, product of roots alpha beta is going to be equal to 3. Now, let's look at what was required. So they wanted us to use these roots to form an equation. So you find the new sum of roots. You sum up those roots that you are given. So summing them up and combining everything that according to powers, you remain with this. So you will prime factorize out the negative here so that we can get alpha plus beta, which we already have in our question. So always make sure that you see that. Always there are some components of prime factorization in quadratics. So make sure that you have the mathematical eyes to recognize that. And this one has its expansion like we have been looking at in the previous questions or examples. Then after getting all expression in terms of either alpha plus beta or alpha beta, you just substitute. So substituting for alpha plus beta, you get negative 2. And substituting for alpha beta, you get 3. Substituting for alpha plus beta, you get negative 2. And then summing everything up, you're going to get 0. And that's literally okay. Now some students get scared when they do that. And that's why we keep setting such questions so that you can run away. Always you should be confident with your answers. And then we get new product of roots. So opening up brackets, we are going to get this. Always we prime factorize out the negative once it's common on two components having the same powers. So prime factorizing it out will give us a standard expression, and we know the substitution for the standard expression. For this one, for the first item we use indices and we prime factorize out the power. Now after expressing our expression in terms of either alpha plus beta or alpha beta, the next thing is to substitute. And substitution, we always advise to use brackets, because once we see brackets, we always put a bonus mark there, knowing that you did some good substitution, and substitution carries marks. So 3 squared is 9, and simplifying this bracket will give you 10, then plus the 3 which was already present outside. Then adding up everything, 9 minus 10 plus 3, you're going to get positive 2 as your new product of roots. So since we have the sum of roots and product of roots, the next thing is to find equation that was being asked for. The equation is given by x squared minus sum of roots of x plus product of roots. So doing that, you end up with this, x squared plus 2 being equal to 0. And then in another example, you are given alpha and beta to be roots of this equation, and you're being told to find the equation whose roots are the following. So how are you going to deal with that? So you're saying that you're going to set a solution. Now here, what is varying only was that they didn't give us figures, they used unknowns, but the approach always remains the same. Always remember that. You first consider whether the coefficient of x squared is positive 1. If it's not, you divide through by that coefficient. but in this case it's positive 1. So our sum of roots alpha plus beta is going to be the negative coefficient of x. So the negative coefficient of x is going to be negative p. That's why you're having positive p as your sum of roots. And our product of roots is always other values that do not have any x variable attached to them. In this case, it's only 2. So product of roots is equal to 2. So this is not supposed to be 1, it's supposed to be 2. So we find the new sum of roots which were given in the equation. Always when you are approaching fractions, the first thing to do is LCM. So once you find LCM, you get an expression like this. And then you find that these two have something in common, which is alpha beta. So prime factorizing it out, you remain with such an expression. Always prime factorization is common in quadratics. So if you're poor at it, you should be very careful and you should do more numbers for practice. And we prime factorize out negative or negative beta and negative alpha so that we remain with alpha plus beta. Now we further expand this one because this one you have been looking at it in each and every example to be having a standard expression which is present in the logbooks. If you don't have a logbook, by 1. So substituting for this one, you're going to get alpha plus beta squared less 2 alpha beta. Then everything divided by alpha beta. Now since our expression is in terms of either alpha plus beta or alpha beta, we make the substitutions. So making the substitutions, in this case, sum of roots was p, positive p, that's why you put it here. And product of roots was 2, that's why you put it here. Always you advise to use brackets when you're substituting because we shall award the mark there. Now simplifying, you are going to get an expression like this as your new sum of roots. So you also find product of roots. Finding product of roots, you have your LCM as alpha beta. Now you correct items according to powers. So you prime factorize out negative on these two. And then using indices, you prime factorize out the cubed on each of them and you put it outside. So remain with the bracket of alpha plus beta cubed less this one has a standard expansion. So you put it there as written in the logbooks. And after getting your expression in terms of either alpha beta or alpha plus beta, you make the substitutions and you end up with this. After making the substitutions, you try to simplify according to where you can stop, and then you get a bonus mark for that. Now that you have got the new product of roots and the new sum of roots, let's go and find the equation. Equation is good from x squared minus sum of roots of x plus product of roots. So you just substitute. Now you can either leave your answer here or you can multiply through by the LCM to get the linear component. You are always going to get the same marks. Now here we have another question. Now since these questions are involving the same approach, I'm getting bored doing them. So I'm just going to be very quick in these ones. They're telling us that if alpha and beta are roots of the equation ax squared plus bx plus c is equal to 0, express this one in terms of alpha, a plus b, and c, hence reduce the condition for the roots. Now what you need to do is to open the brackets, and after opening the brackets, you correct each and every element according to powers. Each and everything is going to align up. First of all, if you look at the quadratic expression they have given you, the coefficient of x squared is not positive 1. So what do? You start by dividing that coefficient to make it positive 1. So you divide through by a. And then you remain with x squared plus b over a, x plus c over a is equal to 0. Sum of roots alpha plus beta is going to be equal to the negative coefficient of x, which in this case is going to be negative b over a, as written here. And product of roots is going to be the other component without any variable of x attached to it, which will be x over a. Then you come to what they have told you to simplify. You open up brackets, you end up with this. You correct powers, you correct terms according to powers, and then you prime factorize all the common terms. So in this case, negative 2 was common. We got this. So this one has a standard expression, and it will lead us here. Now since everything is in terms of alpha plus beta or alpha beta, you make your substitutions. So in simplifying, you end up with this. And further simplification and finding LCM, you end up with this. Therefore, if you look at the else condition, for the root, hence deduce for the root to be twice the other. For one root to be twice the other, that means that our answer is going to be equal to 0. Because if you put here, if you put here, if alpha was equal to, for one root to be twice the other, they mean alpha is equal to 2b. So if you substitute 2b here, if you put it here, you'll find that this is going to be 2b, 2 beta minus 2 beta, which will be 0. So that's why we are saying that if one root is twice the other, everything is going to be 0. So you come back to your expression that you got, and then you equate it to 0. So you remain with, you cross multiply, you end up crossing out, losing the denominator. So implying that your numerator will be equal to 0, and then you make 9s the subject, and you remain with 9s is equal to 2b squared. So I hope that has been simple to understand. These questions are involving the same approach. So I'm leaving them naked without explanations. You take them down and you test your understanding. You pause the video and you take the notes. Pause the video, write the question, and first try it by your own, and then you look at my solution. I know some of you are big-headed. I said don't look at my solution. Try to frame out your solution. Test your understanding. Now for this question, this was a continuation error. So you abolish it or it's omitted. There's a question which it went missing in the processing. So if you go to another example, now another example is a different case. You are always given two equations, and then after giving two equations, they tell you that they have a common root, and they tell you to show or prove any expression. So the first thing to consider here is always whenever you're approaching these questions, you always start by letting. Students make a mistake and they start by calculating right away. That's very wrong. We are going to get everything wrong. You start by letting. So for this equation, we let the common root to be alpha. After letting the common root to be alpha, you substitute and you change the variables given in the question. So that's the first step to earn any mark on such numbers. If you don't start by letting, you are going to lose all the marks. So after letting, our equation 1 is going to become alpha squared plus p alpha plus 2 is equal to 0. And our second equation is going to become alpha squared plus m alpha plus k being equal to 0. So let's see on the next slide the calculations. All you should aim at is eliminating the squared component, and the squared component in that case was alpha squared. So how can we eliminate it? Using elimination method, we just need to get equation 1 and we erase it from equation 2. Now you're going to remain with this expression. But remember, we need to make our common root the subject, which is alpha. So we shall take each k and 2 and k this side, and then you remain with 2 minus k, and then we divide by. Now I prime factorize out here negative and interchange the setting of this, because in the proof m comes first, p comes last. So prime factorizing out a negative enabled me to rearrange this, and then I divide through to make alpha the subject. So alpha in this case becomes 2 minus k divided by m minus p, and this is going to be our equation 3. Now you get equation 3 and you substitute it in any of the equations. You make the equation linear and you make what they wanted in the proof the subject. So substituting it, you are going to have this expression. Now you're going to realize that the LCM is going to be square bracket of m minus p squared. So you multiply everything by the LCM and you end up with this expression. Now simplifying further, you have to open this bracket, and opening it, you multiply it by 2. So you end up with this bracket. So further simplification, you simplify to a point that as you are looking further, telling you to prove until you see that everything is coming in line. I already wrote this and there's no way I can try to show you that, but that's the way we can attack this question. So you find that P2 minus P2 go away, and then you remain with 2m minus Pk. And then you open up the brackets further, or you rearrange this further. Now the rearrangement which was done here, we prime factorize out a negative. That's why this sign changed from positive to negative. And then we change the arrangement of this just by prime factorizing out the negative. And then you take everything this side. So since all of this is negative, when it comes this side to become positive, which was required in the question. Now if you look at the last example, you are given this question and they tell you to form an equation with these, whose roots are these. So always the coefficient of x squared here is not positive 1, so we start by dividing. So that equation will turn to x squared plus 2 over px, then plus r over p is equal to 0. So the sum of roots is going to be negative 2 over p. Product of roots is going to be r over p. Now always sum of roots, anything concerning fraction, you start by finding LCM. Then you end up with this. You open up brackets, you end up with this. Further simplification will take you here. Now, after getting everything in terms of alpha plus beta and alpha beta, you make substitutions. Substitutions and simplification will bring you to this. Further simplification is going to bring you here. And then you get product of roots according to this. Then you form an equation according to the formula until you get your final answer. So that was it for this video. We meet in the next video concerning trigonometry. Candidates who are having their papers this year, you are with success. And for others that are still proceeding, you are advised to keep grinding. Everything is possible when you put in the work. So this video has been compiled and presented to you by U.A.C.E, and you can reach me out on these contacts for any assistance.